Hey everybody, my name is Itai from Hyro. I'm a software engineering team lead, which is responsible for the NLP at Hyro, and I'm going to talk about it in a minute, like what we do and all that. And my talk is about using LLMs in production in the wild. I think there are so many things about. Okay, I'll restart this one. Okay. Hi everyone, my name is Itai. I'm a software engineering team lead at Hyro. I studied computer science and linguistics, and my team in Hyro is responsible for the NLP engine that's inside our virtual assistant, and I'm going to talk about it in my talk. My talk is going to be about using LLMs in production. I think there's so many things out there telling you how to do POCs with LLMs or show some cool stuff that LLMs can do, but not many companies or people have done it in production. And I think, as you all know, it's a totally different story with totally different challenges. And I'll share some of what we do in Hyro for this. Yeah, so let's see what we're gonna talk about. So first, we're going to talk about Hyro before LLMs, but really short, like what's our product and what are we trying to solve. Then we're going to talk about what did we do with LLMs. We use them first as extractors, or like at the understanding level, then as classifiers, and at the end we use them for retrieval augmented generation. And at the end, I'm going to talk about why not LLM only. I mean, you might be thinking at some point, like you guys are working on a virtual assistant, so why not just plug in ChatGPT and save all the other burden. So I'm going to talk about the hybrid model that we suggest. So let's begin. So first, I'll introduce Hyro in a second. So our product is a virtual assistant. It's multi-channel, meaning that it could be either in chat, voice, or SMS. And it's basically for healthcare providers, mostly big hospitals in the US. And the other thing that you should know, that it's a goal-oriented chatbot, like or assistant. Then, like, if there's a scale between chit-chat bots like Siri or Alexa, this one is more goal-oriented. Like, we're not really interested in what the assistant thinks about the weather. Its goal is to schedule appointments with doctors, find doctors, and answer common questions that patients ask. Here's a little. Yeah, here you can see how it looks. It's a widget. You can say, I'm looking for a PCP. You can then add other things that you want to say. Got anyone who speaks Spanish? Then you'll get other doctors. You can also filter on many other attributes and maybe schedule with the doctor you want. Okay, so yeah. So let's start talking about what are we trying to solve. Okay, so building an assistant is hard. I think the main thing that we're trying to solve in Hyro is the time it takes to get to production. Why is that? I mean, why does it take so much time? It's because, first of all, training on clients' data is problematic. Why? Of course, it lengthens the onboarding time. You need to collect the data and then train and maybe retrain. It's not that adaptable, meaning that if for example, if a pandemic strikes, then you have to retrain everything. But even in a more in a more common case of just like a new specialty that's been supported in the hospital, you need to retrain most of your data, which is expensive. Another thing is that end-to-end intent detection is also problematic, meaning that like a model that gets a string from the user and outputs an intent is also not that modular. You can't reuse many things, and also has high maintenance. Pretty much like the training, the reasons for why training on clients is not as good. Lastly, because it's a goal-oriented bot, you might need to query on a client's database. For example, get all the providers given a certain query, then you need to query the client database. But the schemas vary, right? Like every client has their own schema. And also converting natural language to a query is already hard enough. So it's very hard to make it adaptable to each and every client. So this is about the problem that Hyro is coming to solve. And here's how we're solving it. We're solving it basically by two things. One is linguistic rules and with off-the-shelf models. And the second thing is standardizing to a schemaless knowledge graph. So regarding the first thing, basically means that instead of an end-to-end model, instead of a model that gets a string and outputs the intent of the user, we use linguistic rules. We try to model the language. We try to actually understand what the user's talking about with the help of off-the-shelf models. By off-the-shelf, I mean things that are already a commodity. For example, when the company was started about 4 years ago, named entity recognition was already a commodity. So you can have a really good off-the-shelf model without training or anything else that's working pretty good if you want to identify, I don't know, names, locations, or whatever. This allows us to get set free of all this like retraining processes. The second thing that we do is we standardize our the client's knowledge into a schemaless knowledge graph, like a graph database, which allows us to query all clients the same way and be very, very flexible and adaptable. So yeah, that's about how we deal with things. I'm gonna elaborate just a little bit about linguistics because it's not, it might not be super clear. So as I said, we're trying to model the language, not the intent. We're not trying to make some sort of like a tree of intents or something. So basically what we do, we take an utterance like this one, a cardiology doctor that speaks Spanish. We map it, we parse it syntactically. Then we try to map words with these off-the-shelf models that I talked about. For example, if there's a like a specialty, then we have a model that identifies medical specialties. Pretty easy. And then we apply context-free grammar rules to get a query out of this. This is actually a query, right? So you can say we're looking for all A's in the database, such that A is a provider and it has these attributes: Spanish and cardiology, right? So this is the query. This is already number 4. And then we get all the results for these are all the doctors that match these criteria. Great. So I spoke about our linguistic approach. So what's the problem with that approach? Why don't we just capitalize on that? We don't need ChatGPT or something. So I think there are 2 main problems. One is that linguistic rules are too global. And context-free really means that we don't see the whole sentence in context. We just look at subtrees of this tree, for example, like at each subtree, and not at the whole sentence, which can pose problems. For example, given this user utterance, let's say a user said 1111, then this could be a social security number, and we have it in some of our use cases. It could be a date. And it could also be an amount, and we don't have a really good way to know that. And of course, like if you take in the context of the whole conversation or something, like maybe the last question that the bot asked is, what is your social security number? This makes it much easier a much easier task. So that's like a shortcoming of our linguistic rules. The second shortcoming is the fact that these rules are very language specific. Like if you look at this tree here, then it only gets like the English grammar. Like let's say I want to do it in Spanish or in Chinese or I don't know, then I would need different grammar rules, different parser, everything would be different. And so those two main shortcomings led us to think about changing our approach. Great. But I must say that while it has its shortcomings, it still have a lot of advantages. For example, the fact that it's you don't need to train, and the time to go live, like from the time that a new customer signed a contract to the time that they can have an assistant on their website or on the phone, it could be very, very short. Great. So now let's talk about the main event, GPT. So remember I talked about off-the-shelf models. So basically, it looks like all NLP is now off the shelf, right? Like the barriers for entry to the NLP space are much lower now. So basically, like if as I said in 2018 or 2019, named entity recognition or sentiment analysis were pretty much solved for like general use cases. Now so many other things are solved, even very, very specific tasks with this like Swiss Army knife ChatGPT. We as a result, we formed a team called the GP team, and we like the goal of this team was to understand where can we add this GPT magic to our product. And we divided it to 3 levels. One is understanding, which is like the easiest one, because it's not like actually letting ChatGPT answer the user or something. It's more like extracting data from the user. Classifying, which is something we need sometimes, and retrieval augmented generation. And these are basically the things that I'm gonna talk about. Yeah. So, and here's an atom bomb. This is ChatGPT. Okay. All right. So let's start with the first one. Let's start with talking about how to use it for understanding. So basically, we look at LLMs as on-demand models. It's like solving these small NLU problems that are perfectly solvable by a custom model, but are so much easier using an LLM. For example, I think the best example would be this one, the number of people. So we had this question in one of our use cases, like the bot asked the user, how many people are you in the house? So of course we can create like a custom model for that, like that gets a user utterance and returns an int with the number of people in the house that's living in the house. But it's not our main thing in the product, right? Like it could take maybe a month's work to actually collect the data, train this model, deploy this model, and then like be able to use it in production. But with LLMs, it's so much easier, right? You can write something like this, very simplistic like string, understand how many people the user is talking about, return only a number. Okay, and this should work also for some harder cases like this one. Like we found out that 25% of people don't say don't answer with a number, but more with like a story, something like this one, like we're a married couple and a dog. So it's very hard to understand that with linguistic rules, of course. It's not that hard, but a lot of effort to do it with a custom with a dedicated model, and it's so much easier to do it with an LLM. So this is like some calculation I did here. Like we're like, in order to do that, we hired like a prompt engineer plus conversational evaluator. So they tag the problems. It takes them maybe 2 days. Only the problems. They don't need to tag like a huge data set. They build the prompt. They can do it without an engineer, right? Like it's only just like string manipulation and then like just running it over and over. And then they give it to a software engineer, and they add it. The software engineer can add it to production. And also adding it is so easy, right? It's only like if you have the infrastructure for running an LLM, it's only adding this string and a placeholder instead of this instead of the user utterance here. So, and just like taking this 2, converting it to an int. It's like this like so trivial code, so much more trivial than, I don't know, deploying a PyTorch model with its own machines and all that. Yeah, so we did it for some other stuff like emails. But that's like a hard example. Sometimes people read it on the phone, and then they repeat themselves. So it's amazing how this thing like saved us like months of time. So I think that's about understanding. As soon as we finished working on that and integrated into our product, we thought about like what should be the next step. So the next step should be classification. Why? Because one of our use cases is on the phone, is replacing an IVR. Okay, an IVR of a hospital. So people call the call center, and then they need to get to their to the route that they want. Okay, so this is why it's called call routing. Let's say I want to refill my prescription. So I used to call the IVR and then press 1 and then press 2 and then press 3. So we're offering something that's like flattening this like tree of call center intents or routes. So wait a minute. Yeah, so it's the second example here. So basically we said something like, okay, so here are the routes, like schedule, reschedule an appointment, canceling, medical records assistant, prescription support, whatever. Here are the routes. Now understand what the user wants. So basically what happened here is that we failed miserably, actually. Like we had so many iterations on this. And we really failed. Why? Because it triggered too many routes. So basically, someone would say prescription status, which only actually refers to one thing here, prescription refill status, and then we would trigger all of these routes that are even pretty close to the status thing, but they're different. So the thing with the routing was not that easy. You might be asking, why not fine tune or just like train a model that's doing it? The answer for this is that the routes change very, very often. Like about once a week, we get a new route, a new route or a route that's been split into 2. Like, I don't know, maybe schedule and reschedule. It could be the same route, or it could be 2 routes, or 2 routes that are merged. So if we trained a dedicated model for that, then we would have to retrain it every other week, maybe, or even every couple of days. And we would need to have a model for each of our customers, right? Because each customer has its own routes. So yeah, it's not that easy, actually. Another thing that we tried is to negotiate a time slot when someone is scheduling an appointment. We have the available time slots, and we asked GPT to look at the user entrance and suggest them with the most relevant slots. What happened is that it made updates. So basically, we would give the LLM. We use several LLMs there. We would give the LLMs a list of these things, and it would just like mix up dates or make up dates. So yeah, that was another thing that didn't quite work. Actually, after all of these all of these trials, I ran into a paper showing that the ChatGPT is not that good in information retrieval, and actually how do you call it, in classification or topic understanding. Yeah, so letting an LLM, that's like the conclusion from here. So letting an LLM choose from a set list is not good, and it's better to let it freeform. Okay, now we're on the last thing that we did with LLMs was retrieval augmented generation. So basically what we do, actually I think this one explains it better. Wait, this one, yeah. So basically we scrape the client's website, and we answer questions based on the website. Like, here's an example: can I add my teenager to my car insurance? And then there's the full example and the full answer and some suggestions, like these are the pages that it's coming from. Okay, so basically we retrieve the most relevant pages to the user utterance, and then we generate a response accordingly. Here's another one. So I think this pretty much works for all of them. Like there is some kind of a long tail of questions that patients ask us, right? Like it's not like how long does it take to become an anesthesiologist. It's not like we're not going to develop a feature just for questions like how long does it take to become some sort of specialty, right? Like it's not the reason clients pay us, but there's so many of this. Like the long tail is pretty long, so so it really gives us good coverage of patients' questions. So basically, this is like another schema of how it works. We're not actually using these models, but let's say a question is coming from the user. We embed it, and then we see what are the most similar texts from the website are, and then we put it in a prompt, and then we ask an LLM to construct an answer based on all of these. Okay, so we learned a lot about, like, we have it in production for a few months now, and we learned a lot about it. So first of all, or maybe the most interesting thing is that we understood that we should like I think there's so many in the literature about hallucinations, but we understood that like at least in our case, hallucinations are not the right thing that you should address. And they're more urgent problems. So we divided it into three kinds of problems. The first one is a scraping problem, right? Like we didn't get like the right answer is not in the data source. The right answer to the user's question is not in the data source. Another one is a retrieval problem. So the right answer is in the data source, but it was not retrieved by the embeddings or whatever retrieval method you're using. The third one is a generation problem. So the right answer is retrieved, like it's in this prompt here, like in the context part of it, but the LLM didn't like compose the wrong answer. So I think this, like, as soon as we understood that this is the categories that these are the categories that we need to address, it made it much easier for us to fix problems, because we understood where to fix. So basically, hallucination is more a generation problem, right? It's like when the LLM makes up things. So yeah, so I think what we understood is that at least in our case, retrieval was the main thing. Improving your embedding models, improving your whatever heuristic you use for retrieval is key to improve retrieval augmented generation. Another thing that we understood is that real time is a real barrier. Like, let's say we're trying to answer the user, and we need to do it in a short period of time, like maybe 3 seconds, maybe 4. If one call to the LLM takes like 1 second or even 1.5, then it doesn't leave us enough space with, you need networking and other latency and speech to text and other things. So it doesn't leave us much space. So we're not really able to run more than one sequential prompt, which really leaves chains off the table. So these are the main lessons that we learned. I think now we're going to talk about, like, why not, after you've seen all of these things that we've done with LLMs, I'll now address the question that I posed in the beginning. So why not LLM only? So, like, why not just take ChatGPT and give it the user utterance and then let it output and take its output and just render it nicely for the users to see. So I think the main things are that first of all, that clients need control and explainability. They need to understand what's going on. The second thing is that today's model are fragile in the sense that if you change even like a small thing in the prompt, it can change the whole answer. And in our case, specifically in the healthcare industry, it's very problematic. Like, if somebody adds a space or a comma, it can change like the advice that the assistant gives them. So it is problematic. I believe that future models will solve it, but we'll see. The third thing is that since we're a goal-oriented assistant, then we need to interface with external APIs, right? Like, we need to schedule an appointment, so we need to interface with some API, or we need to query some database or whatever. And we feel that this thing is still not mature enough. It is progressing really, really fast with agents and with code interpreter and all that, but it's still not as custom as we want it for our clients. And we can't have it. We can't have mistakes there, right? Like, if we're going to schedule the wrong appointments for the wrong patients or something, it's not going to be good for our clients, right? Nor for our patients. And basically, this is this is pretty much proves the first two things that I said. Like, the clients, they look at our conversations and they just say, okay, this is weird, this is incorrect, this is a problem, this is nonsense, whatever, and we need to have the ways to fix it. And it's very hard when it's an LLM end-to-end solution. So that's why we have our hybrid approach. So we're just like keeping LLMs under control, and we use it. We use fallbacks, and we use LLMs as our off-the-shelf models. We don't use it as an end-to-end solution. We got them covered with fallbacks and other stuff. I think that's about it. I think the hybrid approach is the best approach to keep LLMs under control and not letting them do everything for you. This is the TLDR of my talk. Like, hallucinations overrated, real time is hard, and hybrid is better than LLM end-to-end. This was my talk, and if you have any questions, you can ask me or email me. And we're hiring engineers at Hyro, and it was lovely to talk to you guys. Thank you. Bye bye.